Hello everyone, and welcome to the presentation of this work titled Mutation Testing and Self-Peer Assessment, Analyzing their effect on students in a software testing course. Let me introduce the authors of this work. The person who speaks is Pedro Delgado, and the other co-authors are Inmaculada Medina, Miguel Ángel Álvarez, and Kevin Valle, from the University of Cádiz, and members of the UCASE research group. The experience reported in this work took place in the context of the subject software verification and validation, where students are taught the fundamental concepts and techniques related to software testing. In the last few years, we had identified several issues shared by many lecturers in similar courses. First, current academic curricula in software engineering still place much more emphasis on development and design than on testing. As a result, students may feel that designing test cases is unproductive, mainly because they don't see an immediate benefit. Consequently, students may not become aware of the importance of applying advanced testing strategies. Therefore, a challenge in software testing education is to make students perceive the benefits of writing tests. To achieve that, effective and innovative teaching methods are required. Among the most popular proposed methods, peer testing has shown useful because it exposes students to different solutions to the same problem and offers the opportunity to share their knowledge with their classmates. The second widely used testing method is mutation testing. This technique is based on the insertion of syntactic changes in the code of the program called mutations. This process generates a pool of buggy versions of the program called mutants. And this is quite useful because it allows students to directly observe examples of possible faults that their tests may not be able to detect. Moreover, it gives an objective measure of the quality of the test suite, the mutation score. Well, several studies have described the possible benefits of using these techniques. However, in this experience report, we explore in more depth what is the effect of applying these two approaches on the student's perception. We designed an experience in which we combined two different aspects, two testing approaches, manual and automated, and the opinion on test quality of two different solutions, self and peer assessment. On the one hand, by contrasting their subjective assessment with impartial score offered by mutation testing, we expect students to become more aware of the benefits of applying advanced strategies. On the other hand, by comparing their tests with those of their peers, we want to analyze the extent to which students are able to discern between the quality of two different test suites. In this experience report, we seek to answer two main research questions, one for each of the two testing approaches. The first one, what is the impact on the student's perception when they apply mutation testing to their manual tests? The second one, what is the effect of reviewing each other's code in this experience? Note that we have two more additional research questions that we will present later on in this presentation. Well, let's describe how we designed these experiments. First, we collected the results of 20 different students that enrolled in the course in a period of 3 years. We divided the practice lab in two well-defined sessions. In the first one, students had to manually design a test suite as adequate as possible for a program that we gave them. In the second session, it was their turn to apply mutation testing and observe how effective their manually designed test suites were. At the end of both sessions, they were asked to evaluate their own test suite and the test suite of a peer. Note that they had to value exactly the same test suite in both sessions. We provided them with the necessary material, the tool, the manuals, and you can find them in the link at the bottom of this slide. Regarding mutation testing, they had to calculate the mutation score, which is the ratio of mutants detected by our test suite to the total number of mutants generated. To refine this measure, we discard the number of equivalent mutants, those mutants that do not modify the semantics of the program. For the application of mutation testing, we explained to them how to apply MuCPP, a mutation tool for C and C++ programs. This tool has a broad range of different mutation operators to produce different types of mutations. As for the assessment criteria to help students validate the developed test suites, we defined 5 criteria that covered different aspects related to test quality. First, correctness. Also, completeness and assertions, both directly related to the fault detection ability of a test suite. And finally, design and legibility to encourage readability of tests. For each of these 5 criteria, they had to assign a value in the range 1 to 4, being 4 the best mark. Well, let's then pass to show and discuss the obtained results. First, the results of the first question related to the effect of knowing the mutation score. As you can observe, the mean mutation score considering all students was quite low, 31%. Indeed, only 3 students were able to detect over 50% of the mutants. These poor results actually had an impact on their perception. As you can see, in their self-assessment after the first session, the average mark was 3.0. However, when they already knew the mutation score in the second session, the average mark fell from 3 to 2.6. A similar situation happened with reviews made to their peers, falling from 3 to 2.5. Focusing on the individual criteria, the greatest differences appear in completeness and assertions, both directly related to the mutation coverage. Let's pass to the second research question about the effect of introducing self and peer review. We performed a correlation test between the mutation score and the marks assigned in the subjective assessments. With this statistical test, we wanted to observe whether an increase of the marks in the assessments corresponds with a similar increase in the mutation score. In the first session, when they assessed the test suite without any guidance, we find a medium correlation. However, in the second session, when they already know the mutation score, the correlation is high. This result is very interesting because that means that students are able to perceive the difference in quality of 2 different solutions. They are even able to recognize that the solution of the peer is better than their own solution. The most notable decreases in the marks between the self and peer review were found in the criteria design and legibility. This result corresponds with our expectations that a test suite is not as readable for others as it is for its own designer. As we said previously, we completed the study with 2 additional research questions addressing more technical aspects. With the third one, we found that the size of the test suite was correlated with the number of mutants detected. However, this correlation was far from being perfect. It can be useful to stress this result in the classroom to show students that it is not only the quantity but also the quality of the test cases that matters. With the fourth question, we wanted to know whether students pay the same attention to all programming features. We analyzed this by observing the coverage of each mutation operator, because each one targets a different programming feature. In this table, you can observe the operators that generated some mutants. And what we could observe is that some mutants associated with advanced features, those highlighted in red in the table, went unnoticed by most of the students. Therefore, programming courses should underscore the problems derived from the wrong use of these advanced features. Finally, we can extract some lessons learned. With this experience, we could observe that the mutation score significantly decreased the expectations the students had on their test suites. According to this, and thanks to a questionnaire that they completed at the end of the experience, we can say that applying mutation testing after the manual design of test cases is an effective method to make students more aware of the need of using advanced testing techniques. We should note, however, that the survey also reveals a need to develop or adapt testing tools for educational purposes. The results show that peer testing had a positive effect on them. Introducing self and peer assessments can be useful to help students calibrate the relative quality of their manually designed test suites. This study also gives evidence that the importance of design-related aspects should be reinforced in testing courses as they might not be given the necessary attention. We have reached the end of the presentation. Thanks for your attention.
So we are now in the QA of the third paper of this session. Pedro Delgado Perez is here to answer and discuss the different questions and comments about this paper. So please use the chat to write whatever comment or question you would like to do to Pedro. So in the meanwhile, I have a couple of questions. The first one is about the technique, the testing technique that you are using, which is mutation testing. So why do you focus on this particular technique?
Okay. Well, the origin of this experience was that students feel the testing, creating tests like unproductive. They don't see an immediate reward of writing the tests. So we wanted to create an experience that was like shocking for them,
Okay.
in the sense that they could see a difference, a great difference between writing tests without any guidance, like manually, completely manual, in a manual way, and well, the difference with a very strong testing criterion like mutation testing, like the mutation score. Yes, I think it was successful in this way because some of the students, when on seeing the mutation score, like 10% or 20%, they felt like, how is possible? How is possible?
Yeah.
And they really felt like prompted to inspect some of the mutants to know what was going on there, to know or to understand why the test suites were not able to detect the mutants. No? I think it was a good idea because mutation testing provides those artificial faults, but it is something that they can inspect, they can review, and it's something like tangible. Huh?
Yeah.
Well, I think mutation testing is increasingly used in some of the papers or some of the experiences in software testing courses. So it's increasingly famous. Yes.
And do you think that it could be applicable to other testing techniques? The same approach that you are using?
Yes, yes. I think it could be easily uh, extrapolated to use other testing criterion like I don't know, coverage, branch coverage, or something like that. Uh, yes. What I have to say is that some other works in the literature have shown that some other metrics like statement coverage or brand coverage usually overestimate the quality of the test. When comparing the mutation coverage and branch coverage, there is a great or significant difference in the maybe a test suite has I don't know 90% of statement coverage, but the mutation score might be completely different because mutation testing tests the ability of the test cases to reveal the faults. This is something that other testing criteria do not focus or are not able to test clearly.
Okay. Okay. Then I have another question. Now that you have gathered this all the knowledge regarding to this experience, if you have to replicate this experience again next year, let's assume, what would you do differently, or would you do exactly the same? Or?
We are happy with the experience, how we conceive the experience, because I think it was successful, but probably if I had the opportunity to repeat the experience, probably I would have added like a third session in which they had to generate or write new test cases to try to kill or try to detect the mutants that the test suites did not reveal in the second session. Well, to see how much is the improvement achieved thanks to these mutants, or even if they incorporate some of the knowledge of their peers test suites, the test suite that they had to inspect of the peer, if they incorporate some of the test scenarios that they didn't conceive in the first in their own test suites, or even I think another interesting idea could be to provide them with another program and see if the benefits of the experience having, or they are able to take the to take the lessons learned of the first experience and put it into practice in another, when repeating the same experience with another program. If they are able to think of the mutants when writing the test, if this provides better results.
Okay, good. Thank you. So we have a question from Nelly. Thanks, Pedro, for the presentation. I have just one question. Which kind of systems were used in the software testing course? I think it would have influence in the selection of the mutation testing technique, right?
Yes. Well, we provided them with a program of C++ program, two classes. It was not very complex. It was more like a low to moderate complexity. We selected a mutation tool that worked for the C++ program, for the C++ programming language. Sorry. I don't really understand the intention of the question, but yes, what we used, it was a not very complex program in C++. The mutation tool only generated 39 mutants, which we think it was more or less manageable for the students, because if it had been a great amount of mutants, it could have been a lot for them. Or so yes, I think more or less 40 mutants. It was okay, because these mutants were generated by different mutation operators, by 15 mutation operators, which provides a range of different kind of faults that could appear in a program.
Okay, good. So we still have 1 minute, one more minute for questions or discussion. Is there any other issue, please? Pedro, if there is anything that you would like to add from this experience, from when you wrote the paper until now. It has happened sometime, so you want to add something?
Well, we indeed have repeated the experience in this last year. Online, everything online. It was the first time. It was not as easy as in the classroom, but yes, I think we are going to maintain this experience. Maybe we will change something in the future if we want to test something else or something. But yes, we think it's like a good complement to the practice labs, because yes, we taught them how to put into practice some testing tools, and we teach them a lot of many testing techniques, advanced testing techniques, but sometimes we feel that they don't really understand what they are doing, or the importance of doing that. They just write tests